This skill module covers primary and remedial cementing at the core knowledge level. This section discusses why this topic is important. Primary and remedial cementing is a complex subject, and it often does not receive the engineering attention that is necessary, but it is extremely important in being able to establish quality wells which do not create fluid influx problems over the life of the well, due to poor primary cement jobs that allow the channeling of water and unwanted gas. If we don't understand proper cementing practices, we might over or under design a casing and cementing program, overspend in attempts to repair poor well cement conditions, lose production and require excess water handling and or gas processing. This module on primary and remedial cementing provides insight into the absolute necessity to achieve competent primary cementing job results when running, setting, and cementing well casing strings. This module illustrates the always negative effects of water and or gas influx into a producing zone that is not properly isolated by the seal established by a quality primary cement job. This module presents the broad scope of cement in a well to not only protect and isolate formation conditions, but also to provide additional advantages, such as to protect casing from corrosion, protect shallow aquifers, support casing within a well, prevent fluid migration behind pipe, modify cement properties design, that is, customize a cement slurry through the use of additives, and to permanently plug and abandon a zone or well. This module also discusses the basics of plug and abandonment operations, when they are performed, why they are necessary, and the correct procedures for performing them. This module discusses various wellbore barriers used in plug and abandonment operations, such as cement plugs, bridge plugs, and cement baskets. Industry data that has been acquired over years of remedial cementing practices is presented. It illustrates the high cost and relatively low success rates achieved in attempting remedial cement squeeze repair of faulty primary cementing failures. Knowing the specific and proper details to properly design and field mix a cement slurry, how to properly prepare a wellbore for cementing operations, how to select and run the proper cementing tools, how to properly displace and circulate cement downhole during the critical pumping sequence, how to rotate and or reciprocate casing during cementing to promote optimum cement placement, how to monitor cement slurry density during pumping, how to gather cement samples during the pumping sequence for compressive strength testing, how to wait on cement WOC curing and compressive strength development, how to test casing string shoe integrity, how to perform plug and abandonment procedures when necessary. All of these and other considerations addressed herein lead to a rigorous cementing program that, when properly executed, will result in fewer post-cementing problems when a well is placed on production. Primary and remedial cementing operations are conducted with the intent of making a wellbore safe to conduct all future well intervention operations by isolating reservoir pressure and fluid flow as part of the overall barrier plan required for each well. Many problem well conditions and situations, ranging from small casing leak issues due to corrosion to full well blowout and loss of well control conditions, have been linked to defective cement jobs which fail to isolate well pressure and flow. Knowing the details and checklist of steps to achieve quality cementing results will prevent this from occurring. Proper engineering design and properly executed primary cementing steps have an acceptably proportional routine cost impact of about 5% of total upon the overall authorization for expenditure AFE for any well. Disproportionately and excessively, the long-term effect of poorly isolated casing strings due to cementing deficiencies lead to life-of-the-well maintenance and repair costs. Similarly, when attempting remedial cementing steps, industry data indisputably documents both the high costs of squeeze cement repair attempts themselves and the lesser than 50% success rate chance of resolving all cement-related problems when attempting cement squeezes. Safety is an integral and basic component of all steps of the oil and gas exploitation process. Well casing, cementing operations require a full and complete understanding of and accommodation of potentially hazardous conditions and their necessary mitigation efforts. Deeper well bores and more complex well trajectories, in combination with increased pressure and temperature, mandate that all aspects of cementing be proven as acceptably safe in materials selection, well intervention, and the placement of cementing tools and cement in the well. Offshore cementing adds a further degree of complication, as modern-day wells far from shore are usually targeting deeper reservoir targets. Cementing standards are regularly being updated and improved to address emerging phenomena that are encountered as wells become more complex and downhole conditions become more hostile. Once the well is no longer producing hydrocarbons, plug and abandonment operations are performed. These are essential to ensure that the wells are non-damaging to the environment and people populations long after the life of the well has ended. In all cases, casing cement and related well integrity over a well's life is the focus of the referenced cementing standards. The module addresses basic cementing standards and practices that result in quality well cement jobs adhering to standards compliance.